Proceed.
Today we are discussing ground launch projectiles.
We're going to follow Sarah performing a jump, gather data in her initial velocity, her acceleration, and the time in the y direction to try to approximate the height of her jump.
Point 6 again.
Now that we have gathered our data, we will create a table to organize it.
In the data table, we have a column for the y direction motion and the x direction motion. Both columns include the initial velocity and acceleration in that direction. The times are different because the time in the y direction is the amount of time it takes to reach the top of the jump. However, the time in the x direction is the time it takes for the total jump to be completed.
Now we must choose the proper formula given the data we've collected.
Because we have her initial velocity, her acceleration, the total distance covered in the x direction, and the entire time it took to travel the width, we are going to use the distance equals VIT plus 1/2 AT squared.
First, we must state the formula that we are going to use. Then we can add subscripts to the formula to help us figure out from which part of the data table we will be attaining our values. Once we do this, we can plug in the values to the formula. To start off our math, we will multiply 4.17 meters per second times 0.3 seconds, and we will square 0.3 seconds. Then, we will multiply negative 9.81 meters per second squared times 0.09 seconds squared. Then we will multiply negative 0.88 meters times 1/2. Next, we will subtract from 1.25 meters 0.44 meters. In the end, we end up with the distance in the y direction being 0.81 meters.
Let's compare the calculated height of the jump to the actual height of the jump.
Now we have successfully calculated the height or distance in the y direction of the launch projectile.
Considering that there was a difference between the actual height of the jump and the calculated value of the jump, we decided to calculate our percent error. Our percent error was 35%. Some sources of these errors may include human errors, such as our timing being off or the placement of the jump being a little too far to the left.
Go.
Sorry, did I mess that up? Now we must choose the proper data. See, I forgot the line.